This video is application of volume. Okay, we want to apply the formulas for volume to real-life situations. The amount of space enclosed in the interior of a three-dimensional object is the volume. So at first they give us some formulas to use. Okay, the first one for prism is the volume is equal to the area of the base times the height. Same formula for a cylinder. However, I like to change this to pi r squared times the height because the base is actually a circle. So the area of a circle is pi r squared. The pyramid is 1/3 the area of the base times the height. The cone has the same formula. And then we have surface area of a sphere, 4 pi r squared, and volume of a sphere, 4/3 pi r squared cubed. So now let's look at a couple examples. Okay, let's see. The first one, an internet bookstore shipping a book to a customer. The dimensions of the book are 7 inches by 4 inches by 1.5. The dimensions of the box in which the book will be shipped are 12 inches by 8 by 2.75. How many cubic inches of packaging material must be added? So here what we have is we have a larger box. See if I can draw that somewhat. So we have this larger shipping box that we want to put our book inside. And so this one is 12 by 8 by 2.75. But inside of here, we need a smaller book. Let's see if I can draw that. Not too bad. And so the book is 7 inches by 4 by 1.2 by 1.5. Okay, so what we need to do is we need to find the volume of both of those, and then we're going to subtract. So let's start with the larger one, and we can just multiply length times width times height since the area of the base is a rectangle, and then we're just going to multiply by the height. So I'm going to multiply 12 times 8 times 2.75. And my calculator should be here somewhere. Okay, so let's see. 12 times 8 times 2.75 is 264. And these are cubic inches. Okay, now we'll do the same thing for the actual book that's going inside. And that is 7 times 4 times 1.5. And so 7 times 4 times 1.5 is 42. And again, these are cubic inches. So we just need to subtract. We're going to take the larger box, 264, and then we're going to subtract 42. And the difference is 222 cubic inches of some kind of material is going to have to go inside that box to protect the books. Could be peanuts. They don't use those much anymore because they're bad for the environment, but some kind of corrugated material or bubble or something like that. Okay, let's look at the next one. The next one says a water pipe has an outer diameter of 4 centimeters and an inner diameter of 3 centimeters. Approximately how many cubic centimeters of material are needed to make the pipe? So think about it. We have a pipe, but we're going to hollow it out. So where it's hollowed out, we don't need the metal material. So we're going to start with the outer. Be careful because they gave us the diameter, not the radius. So we're going to cut that in half and make it 2. And so we will use pi r squared times the height. And so this is pi times 2 squared, and the height is 50. So 50 times 2 squared, 50 times 4 is 200 pi. So that's the amount of the entire thing. But now what we want to do is we want to subtract the hollow part because we're not going to need metal. Again, they gave us the diameter, so we're just going to change that to 1.5. That's the only thing that's changed. So now we have pi r squared times height. So it's pi times 1.5 squared, and then it's still 50 centimeters in length. So 1.5 squared times 50 is 112.5 pi. Sorry, it's so messy. So I'm just going to take the 200 pi, and then I'm going to subtract the 112.5, which you probably can't read. But the difference is 74.5 pi. Okay, and so now what I need to do is, because they're asking us to approximate how many cubic centimeters of metal, is I'm going to take that 74.5 pi and put it into my calculator. And I get 234.049. And 234.049. That sounds different from what I did before, so I'm just going to redo this into my calculator and make sure I didn't make a mistake with my writing here. So 1.5 squared times 50. Yeah, that is 112 pi. Okay, so 200 minus 112. Maybe that was my mistake. Is 87. Okay, this was a mistake here. I knew that didn't look right. It was just a mistake on my calculator. So it is 87.5 pi is the difference. And so all I need to do is let me erase this. And I'm going to take 200 pi and subtract 87.5. Be careful entering in your calculator. So it is 112.5 pi is the difference between 200 pi and 112.5 pi. Now, since it's asking for the approximate, let's go ahead and multiply that times pi. And I get 353.429. And so now I'm going to read, and it doesn't seem like it tells me to round it off to the hundredths or anything like that, so I'm just going to put the entire answer here. 353.429. Okay? Let's look at, I think we just have one more. No, we have two more. Okay. What is the volume of air in the following cylinder if it's filled a quarter of the way with water? A couple different ways you can do this. What I am going to do is I am going to take this 35 and divide by 4. Okay? And so that will allow me 35 divided by 4 is 87.5. So that means this part down here, 87.5, is going to be filled a quarter of the way with water. So if I take my 35 and subtract my 8.75, that tells me that the rest of this, our 26.25, is going to be filled with air. So now the formula for its area of the base times the height, but again the base is a circle, So pi r squared times height. So pi times the radius is 14 squared times my height that's going to be with air, 26.25. Just going to put that in my calculator, 26.25 times 14 squared. And that is 5145 pi. Now that is my exact answer, but they also asked for the approximate answer. So let's go ahead and put that one in there as well. So multiply that times pi, and you get 16163.5. Okay? So now we have one last problem to do. And this one I think is a little tricky for some people. So the problem here is, what is this shape? Okay? A common dimension for a swimming pool is for the depth to change gradually from the shallow end to the deep end. So we're looking at this and it's like, what is this? Remember, it's a prism. The sides are rectangles. And then what is the base? Well, the base here is in the shape of a trapezoid. And so the formula is the area of the base times the height. And then the area of the base is base 1 plus base 2 times the height divided by 2. So if we look here, here is one of my bases. Here's my other base. The height has to be at a right angle. So that is this 36 right here. Okay, so that is this height right here. This is the height of the actual trapezoid. So the height that's going to be of the prism itself is the one that we haven't used, which is 4. So base 1 is 12, plus base 2 is 18. So here's 12. I'm sorry, not 8. I said that backwards. Let me fix that. I'm sorry. Let me erase real quick. Okay, this 4 here is actually the 4 here. I'm sorry. See, this 4, if we look at this here, okay, this is the 4. So that means that the one that we haven't used yet is 18. So this 18 is the height of the prism itself. Okay, so let me fix this here without having to start my video over. Okay, so this is the base, one base, and then the other base is this 4. Times the height of the actual trapezoid, which is this 36, because that has to be at the right angle, divided by 2, and then we're going to multiply that times the height of the prism, and the height of the prism is the 18. Okay, that one's a little tricky. Make sure that you add the 12 times 4 before you multiply. So this is going to be 16 times 36 divided by 2 times 18. So let's see. 36 times 8 is, I get 288 times 18. And that one is 5,184 cubic feet of water. A lot of water in a swimming pool. Okay, good luck with the applications.